Okay, guys, so we're going to talk about the different trig identities and where they come from. At this point in time, you should already know the reciprocal identities and the quotient identities. We already know that sine and cosecant are reciprocals of one each other, and the way to make reciprocal is by putting it over 1 and flipping it, right? So if sine and cosecant are reciprocals, take sine, I put a 1 over cosecant, and there I've got that reciprocal. We should know that by now. I remember teaching you that last semester. We know these right here, but we're not going to use them because we're going to use these instead. So never, never, never are you using these because they will not help you. All right. Now, if I had a unit circle, so if I had this, okay, and I had a triangle inside of my unit circle, which is what we have normally. Here's my angle. Here's my right angle. This is always cosine, and this is always sine, right? Because when I get here and I have a coordinate point, it's cosine, theta, sine, theta. That's what we know by now. And our radius is 1. So if I was going to take this and I was going to do the Pythagorean theorem, if I was going to do a squared plus b squared equals c squared, here I would have sine squared x plus cosine squared x equals 1. That's a squared plus b squared equals c squared, okay? So that is the standard, most basic, fundamental Pythagorean identity. This is an absolute necessity that you know this one. It is the basis for all of the other 8 identities. There's a total of 9 Pythagorean identities. This is where they all come from. So I can take this equation and I can go ahead and I'll solve for sine x. So by doing that, I'll subtract cosine squared x from both sides, okay? That'll cancel this out and that'll leave me with sine squared x equals 1 minus cosine squared x, okay? That's your second Pythagorean identity. I can find the next one by taking that original sine squared x plus cosine squared x equals 1. And instead of solving for sine squared like I did in that one, I'll solve for cosine squared. So I'm going to subtract sine squared x from both sides. Okay, so that's going to get me cosine squared x equals 1 minus sine squared x. Okay, so that's your third identity. So here I have 1, 2, and 3. Those are all the ones involving sine and cosine. Now, I can take that original one, sine squared x plus cosine squared x equals 1. And if I was to take it and divide each one of these by sine squared x, I could do that and I could simplify and I'd find another identity. So sine squared x divided by sine squared x is 1, because anything divided by itself is 1. Cosine squared x divided by sine squared x is cotangent, because cosine over sine is cotangent, right? We've got that right here. So cosine over sine is cotangent. Cosine squared over sine squared is cotangent squared. So this is cotangent squared x. And 1 over sine squared, well, 1 over sine squared right here is cosecant x. So 1 over sine squared x is going to be cosecant squared x. That's my next identity. This is my fourth one. I can take this identity. I can solve for 1, so that means I'm subtracting cotangent squared x from both sides. And that's going to get me 1 equals cosecant squared x minus cotangent squared x. I can do the exact same thing. 1 plus cotangent squared x equals cosecant squared x. So these are the exact same equations, and instead of solving for 1, I'll solve for cotangent squared. So I'm going to subtract 1 from both sides. So that leaves me with cotangent squared x equals cosecant squared x minus 1. So this is your 5th identity, and this is your 6th identity. They're all just taking that same original one and just rearranging it, because you want to be able to see all the different ways that that one equation can be written. All right, so coming back to the original, Actually, let me do it this way, just because it looks better. Okay. Do we agree cosine squared x plus sine squared x equals 1 is the exact same thing as sine squared x plus cosine squared x equals 1? Order doesn't really matter when you're adding. 3 plus 4 is the same thing as 4 plus 3. So these are the exact same thing. It's just rearranged. Order matters when you're subtracting. Okay, so if I was to take this one, and last time we divided by sine, so let's divide by cosine. I divide everything by cosine squared x. I'm going to end up with 1, because cosine squared divided by cosine squared is 1. Sine squared divided by cosine squared is tangent squared. And 1 over cosine is secant squared. Okay? So that's your 7th identity. I can do the exact same thing that I just did to all these other equations. And let's see. Copy. I don't want to write it twice. You can do the exact same thing that I just did. Solve for tangent. So I'm going to subtract 1 from both sides. That gives me tangent squared x equals secant squared x minus 1. And I can solve for 1 and get rid of that tangent. So I'm going to subtract tangent squared x from both sides. And that gives me 1 equals secant squared x minus tangent squared x. Okay? So this is your 8th one, and this is your 9th one. Those are all of your trig identities. On the formula sheet that I gave you that looks like this up top, you should have each one of these, this one right here, this one right here, and this one right here already written on it. You should go ahead and write these directly below each one that they correspond to, so you have all 9 of your identities in one place. So that is where all of your trig identities come from. You have to know that on your tests, quizzes, final, performance final, SPG, the only ones that you'll be given, and they'll look like this: sine squared theta plus cosine squared theta equals 1. And you'll be given cosine squared theta equals 1 minus sine squared theta, and sine squared theta equals 1 minus cosine squared theta. You'll be given these 3. Okay, so the way to get from these 3 to the other 6 is simply you take each one, divide all terms by cosine, simplify. So sine squared divided by cosine, cosine squared divided by cosine, 1 divided by cosine, cosine squared divided by cosine, 1, so on and so forth. And then the next way you do it is to get all of these, every single one of these, and divide by sine. The other alternative is to memorize them. Okay? But these are the only ones you will be given on any quiz, test, or SPG, or your final. Okay? You will not be given any of the others.